Find the limit of the vector valued function. So the limit as t approaches pi over 6, cosine squared, sine squared, and 1. So for this, we can plug in pi over 6 in for t. So you have cosine squared pi over 6, sine squared pi over 6, and then 1. Cosine of pi over 6 is root 3 over 2, so we're just going to be squaring that. And then sine of pi over 6 is 1/2, so square that. And so we get 3 over 4, 1 over 4, and 1 as our final answer. In next limit, we have x and y approaching 0, 0. So 0 and pi over 4 rather. Secant of x plus 2 all over 3x minus tangent y. So this one we can plug in x equals 0, and then y is pi over 4. So secant of 0 is just 1. So that's 1 plus 2 is 3. 3 times 0 is just 0. And then tangent of pi over 4 is 1. So we get 3 over negative 1, and that's negative 3. Last one, we have the limit as x and y approach 0, 0 of x squared plus y squared all over the square root of x squared plus y squared plus 1, and then minus 1. So there's going to be two ways that we're going to find this limit. First, we can use algebra to simplify this. So we're going to multiply by the conjugate of the denominator. So for that, you leave everything the same except the sign here changes to positive. So that's square root of x squared plus y squared plus 1, and then plus 1 here. Same thing at the top. Now, for the purposes of this problem, I'm just going to leave the numerator here as it is, and you're just going to put a parentheses. And note that it's going to be multiplying square root x squared plus y squared plus 1, and then plus 1. Now, for the denominator, we have the case that it's a minus b times a plus b. And for that, we know it's just a squared minus b squared. Okay. So this will play the role of a, this will play the role of b. So you have to square a. In other words, you have to square the square root, and when you square the square root goes away. Okay, so that's a squared minus b squared is 1. B is 1, so b squared is also 1. And notice that the 1s are going to cancel. So you have x squared plus y squared over here. X squared plus y squared over here. Those are going to go away. And you're just left with the square root of x squared plus y squared plus 1, and then plus 1 here. Plug in x and y equal to 0. You get square root of 1, which is 1, plus 1 is 2. So this is going to be the limit. Now the other approach is to notice that r squared is x squared plus y squared. Okay, and this is from polar. So we're going to make a substitution. So for every x squared plus y squared, we're going to replace it with r squared. So that's really r squared over the square root of r squared plus 1 minus 1. And here, r is going to approach 0 from the right. Because r represents a radius, and it doesn't make sense to approach 0 from the left, because the radius can never be negative. So here we're looking at the radius approaching 0 from the right. And in order to solve this, we have to multiply the conjugate at the top and the bottom. So that's basically going to be the denominator, but instead of minus, it's plus. Okay, so I'm going to leave the r squared alone. So hopefully that's going to cancel. And again, here it's a minus b times a plus b. So that's a squared minus b squared. So a squared is just the square root squared. That's going to remove the square root. And then b squared is 1. The 1's are going to cancel, and then the r squares are also going to cancel. So really what's left is this, whatever's inside the parentheses. Plug in r equals 0, and you get 2 as your final answer.